what we did last week is get a really basic behavior running, which is just the decoding of a single video frame of a frame to then display it on the screen. That's all I've got at the moment. And so if I build this, that's what you should see. Yeah, here we go. So we've got this one window with hello world written on it and one color video frame taken from this video on my desktop stream announcement. And that's all we have. So obviously now I want to start animating this and actually playing the whole video instead of just showing one frame from it. But let me go through how this all works so far, just to recap. So the entire project is using CMake to build. So I've got this thing in the root called CMake lists, and I'm doing a few things. I'm adding my two libraries. I have two libraries installed here, FFmpeg and GLFW. I'm ignoring OpenGL deprecation warnings, and I'm linking with the right libraries on Apple, on Windows, and on Linux to be able to get graphics on the screen. And then I've got two source files, main and load frame, which run my whole program. In main, we've got essentially, in main we just run a very basic routine in GLFW. We initialize GLFW, we create one window on the screen, and then we load a frame. So we call a function that we wrote called load frame that will take a path to a file name, in this case users, BMJ, desktop, stream announcement, and will give us back the frame width, the frame height, and frame data, which is just a buffer of bytes. And next, I copy that buffer into a texture. I load it into a texture in OpenGL, and once loaded into that texture, I can have my render loop here. So I'm looping around for as long as the window is allowed to stay open. I'm going to clear the entire screen, and I'm going to set up orthographic projection so that I can just use pixel coordinates, and then I render my texture. So that's the main loop. That's all we're doing. And then in load frame, that's where I've written the code to open up a video file with FFmpeg to find the video stream inside that video file, and then to receive one packet from that video stream that we then give back to the main function to show on the screen. That's it so far. Okay, what I want to do in this stream is start getting multiple frames from the video file, playing back the video file. So the way I want to do that is basically this code that I have, this load frame code, I need to break it up into multiple functions. I need one function to like initially open the file, and then another function where I can repeatedly take out one more frame until all of the frames have been loaded. So to do that, I have to basically, let's see, some of these variables that are just local variables have to become parts of some kind of context. Bless you. So we'll see. Are there any more questions, by the way? Yeah, exactly. Immediate mode is deprecated. I don't think all of OpenGL is deprecated from Apple's perspective. I think you can use OpenGL shaders without any deprecation warnings. But yeah. Right. So, to go back over this code, because I need to get back into this and kind of read and pay attention. So we've got a few different local variables. If I bring these all to the top, got an AV format context here. If I just bring the declarations up to the top, we've got an AV codec context that I care about, and then an AV frame and an AV packet. And there we go, AV packet. What else do I need? And then I have this scalar context, which is a part of FFmpeg that I'm using to convert the YUV pixel data that they have, where it's based on luminance, saturation, hue, to RGB, so that we can display it on the screen. So that scalar context I also want to keep between frames. So of all the variables in this code, and if you want to look through and understand all the code, it's on GitHub, and I coded it last week in a live stream, so you can also watch that live stream. Okay. Are you okay?
Yeah, allergy strike.
Allergy strike, man, that sucks. Okay, so these are all the variables that we want to set up once, and then as we decode frames, we're just going to be reusing all of this state instead of reallocating it each time. So I want to break this up into, I'm going to put this into a struct essentially. And I can call this video reader state. And so, yeah, actually, let me start breaking this up into having video reader dot HPP and video reader dot CPP. Oh God. There we go. So I want to start building a new reader from scratch. I'm going to bring that all the way back to normal there. So what does our video reader do now? We'll have to import these things. We want, instead of one function which just loads a single frame, I want a function which is like video reader open file. Oh, thanks.
Yep.
Thank you very much.
You're all good.
Oh, cheers. Nice. Nice. Okay. So, for the video reader, we need three functions. We need one function to open the video and set up all of our contexts. Then we need one function to like read a frame, or decode a frame, whatever you want to call it. And then one which would just be deallocate, free up our video state. And that's all we want to do. So in the open file, or I can maybe call that init. I'll do open file, then here close file. Or just open. Sorry, this is really pedantic. Okay, when opening, I want a boolean for success, and I give it a video reader state and a file name. And so we want to set up all of our states internally by reading in that file. Let me check if there are more questions as you go along. They've deprecated the whole of OpenGL. Oh man. Are there like translation units that can turn OpenGL code, or it can like take all the OpenGL functions and do the metal equivalent of them? Does that exist? Okay, whilst maybe if I do that, yeah, there we go. Now I can read the comments and and continue at the same time. Otherwise, I'll just forget, and then you stay in the stream the whole time, and I never get to your question. So we have an open, and then a read frame, which probably also has a boolean, and we'll give back takes our state again, and takes like a buffer, and we fill that buffer in the success case. MTLPP. Okay, I will check that out. But for me, like exactly which GPU, exactly which library or framework I'm using for GPU to communicate with it and to set up graphics, I don't care about so much right now. Once I'm gonna do more involved graphics stuff, I might want to do some research there. But I'll stick to OpenGL for now because it's just cross-platform. I don't want to actually get stuck in this corner of only being able to run on Mac. But yeah, that should do for now. So that's our main interface. Video reader open, video reader read frame, and then a close or a free at the end where we can close our video file. So the way our main would look is, instead of doing just a load frame like that, what we might want to do is like we first do if we create a video reader state. I'll call it VR state. And then we give that file that I want to open. If that fails, couldn't open file. And then we just read one frame. Wait. Let's see. Okay, so I have to put more stuff. I want to put more stuff in that VR state. So we've got all of this stuff, which is kind of like private implementation, like private internal state. And then we have like public things for other parts of the program to read from, which would be like width, height, width of the frame in pixels, height of the frame in pixels, and then like a frame buffer.
Would you like sugar or cream?
No, it's good. No thanks. Okay, like this. Okay. Yeah, frame buffer. Don't really care about it. So what I want is that after we, here back in main, after I open the video file, VR state will set the width and the height of the video file so that I can actually, in the main loop, allocate a frame buffer so that I don't have that in the video state. I think that would be better. So here I'll say, now that we've opened it successfully, I can set my frame width there to VR state. I can copy those over. And then I can have my frame data array there. That will be a new... am I using... Yeah, like that. Here I can then just say frame width times frame height times 4 bytes per pixel. And once we've done that, then I can say video reader read frame, giving it the state again, VR state, and a pointer to our frame buffer. So then we'll get our video reader to read one frame out of the file and put it into this buffer. If that doesn't succeed, then I'll just say couldn't read, couldn't load video frame, and return 1. And if we did succeed, then I'm just going to do video reader, read, video reader close. Like that. So originally we had load frame, which does all of this, but now we've broken it up into opening, reading one frame, and then closing. Because now that we've broken it up, we can then repeatedly call that read frame to get multiple frames out of the video file. So, okay, we have to update our CMake list here. Sources, source, video reader, CPP, HPP. I want to include video reader.hpp. Here I just want to say okay, that's the plan. Turn our load frame function into a video reader that maintains state over a longer period of time. Did I make any mistakes with this? Okay. So that's good. That compiles. Let me build this in Xcode. Okay, is everything still good? Stream is good. Yeah. Okay. Let's start on this. So when building, there should be a problem that the video reader functions haven't been made yet. And that's what I expect to see. And that is what I see. Yeah, cool. So now we just have to implement this. So this is going to be, I think, the easy part, because all I need to do is actually just break up, just copy over our load frame and turn it into, split it up into 3 different functions. Just paste it all in. So now what I'll do here, I can just, without having to change anything, I can just unpack members of state by just using references, AV format context. It is the way I'm programming this is very much like you would program it in C. I'm not using pretty much not using any features of C++, with the exception of like an auto reference, just for a shorthand. So maybe later, I haven't decided on how I want to program this. Maybe later I'll make it more object oriented or use classes more. But for now, I don't think it's quite necessary. I think it's more simpler to think about the way a C program works than the way an object-oriented C++ program works. So I'm gonna just write it in the simplest way that I know how to do. So what's wrong here? Oh, it's a pointer, yeah. So if I unpacked it, then I can change that. There we go. So here we first open the file, then we find the video stream that we want, and then we allocate the we set up our decoder, and then we allocate a frame and a packet. And that's everything we need to do to open the file. So now after this, I'm going to return true, and the rest of the code should be in the other functions. So I'm going to cut that and paste it here. So yeah, now we're missing all of these references again. So let me copy my unpack code. Video stream index. Okay, we need to store that as well. Video stream index. Okay. So we unpack the members. Do we use the format? We use the codec and the packet. Yeah. Unpack. Just decode one frame. So at some point here, so we send the packet. We receive the frame. If the response is AVE again or end of file, we continue until we get, like, until we break out of this, essentially. We only break when we've received the frame properly, which is here. Otherwise, we return false. So at this point, we don't need to allocate a new buffer. We're receiving the buffer from our we want to set up SWS scalar in here. So that we can properly convert our video data set up. Here. So here we free the context. We don't want that yet. We want to do all the freeing of context and freeing of stuff only when we do the reader close here. Reader close. Oh geez. State. 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 There we go. Okay, so a few things are still not good. SWS scalar context needs to be unpacked. Okay. So we need to know the width and height of the video before we, like here, because right now my code figures out the width and height only after I've decoded a frame. We need to actually know it before, which means that we need to know it here when looking through all of the streams in the AV format, in the file format. When we find the stream that is the AV video type, we need to determine the video width and height. So width there, and height. Okay, so we've got our stream. If the stream is the video stream, then we want to save our width to be AV stream width. How do we figure out what does AV stream have? Internal. Size would be like frame width. I want to know the resolution. Where do I find that? How do I find the resolution? I thought an AV frame has the resolution built into it, or like written in it somewhere. Huh. Would it be in the codec parameters? Okay, I'm going to comment this out so I can compile the code. Turn false. We were not able to code the frame. So over here, if we find a video file, how do we know the resolution of the video file? Yeah, that doesn't have the data. AV codec params. Okay, the codec params has it. It has the width and the height. So, I didn't need to do that. Creating a new variable for the stream. Here we say width is AV codec params width, and the height is the height. We need to know that so that in main, when we allocate our buffer, we know how big the buffer needs to be. So that whenever we ask the video reader to read a new frame, we give it a buffer that can fit the frame that it's going to decode. Right. Okay, this doesn't work. Probably because we don't have an AV frame right yet. So we need to use the width and the height that from the codec parameters. How do we determine the pixel format? Is pixel format not okay? Pixel format none. Yeah, so because the codec hasn't decoded any frames yet, it doesn't know the pixel format. So we have to find that from, hopefully the codec params has it. No. No. Okay. Maybe it's in the AV stream. Let me check. AV format context. Streams I. Pixel format. Is it inside the AV codec? Pixel formats. AV codec params. How do I determine the pixel format? Well, technically I don't have to. I could initialize the scalar context when I actually do have a frame. Yeah. Okay, let's try that. So I will move this to inside here. If SWS scalar, oh god, if scalar context is not initialized yet, then I will initialize it with those values. Do I have width and height? No. And once initialized, if it's still not initialized, then we've got a failure. And then we have to feed it some information. Width, AV frame data. Okay. What have I just done, and why does it work? So, let's see here. I feel like I've really badly explained all of this stuff. So, let me go over this a bit slowly now, to just get more details in. One sec. So what have I got currently, to give a rundown again of what's happening? So in our main function, we don't need this anymore. I initialize glfw to create a window, and then I initialize my video reader to open a video file. And then I ask my video reader to read one frame. And so what I started off with from the previous stream is a single function load frame, which does all the work in one function. Now I have a video reader, which has a structure containing all of its kind of working internal states, and free functions, one to initialize, one to read an individual frame, and one to close. So we can repeatedly call that read frame function, and it should give us a new frame each time, because what read frame is going to be doing is it will be running this loop of reading in a frame, and that's actually a packet from the format, reading in a packet of data from the file, and figuring out what stream that packet is associated with. So it'll tell us maybe it's an audio packet, maybe it's a video packet, maybe it's a subtitle packet. If the packet is associated with the video stream that we want to decode, then we send that packet to our decoder. And the decoder will then tell us whether it failed to decode, like whether any error actually happened. And if not, then we're going to ask the decoder to receive a decoded frame from after sending it packet data. Now, when we ask the decoder to give us a frame, after we provided it with some data, it might not actually give us a frame, because maybe we didn't give it the right packet, or not all of the frame data has been received yet. It needs more packets. In those cases, the response will be something like, well, end of file error, or something like E again. And then we want to do basically continue, which means we'll go back, we'll read another frame from the format, we'll read another packet. I don't know why this is called read frame if it's actually reading packets. But essentially we will read another packet, we'll send that packet again to the decoder, and maybe this time we do have the data to construct an entire frame. And in that case, the response would be like 1 or a success response. If the response is less than 0, there's a failure, and so we just want to return false. But if it's not E again, it's not error E off, and it's not an error message, then we've received the frame, which means we can continue. We can happily continue, and then we break out of this loop because we've got our frame, and then we set up SWS scalar to convert the pixel data from the internal format of the video file to RGB0. The internal format will usually be something like YUV to save space, and we want it in RGB0 so that we can put it into OpenGL. You can also use this moment here to like scale it, so you can like divide by 2, or you can change the scale of it. That's what SWS scaler does, but I'm keeping it the same exact pixels. I just want to change the pixel color space. And that's all that the video reader will do. By the end of it, if it returns true, that's because it will now have filled the frame buffer we gave to it. If you look at the header here, the frame buffer that we gave, if the function returns true, that frame buffer will be filled with the newest frame that we received from FFmpeg. So that's essentially... Oh, you have an answer. Yeah, see, I don't know that. I don't know about that because... so what Brian is saying is, I think it's called read frame because it is reading a frame, but it might not be a keyframe, and then the decoder would need more to actually assemble an image. I'm not I'm basing this off one thing that I was reading, which was very useful, which is like learn FFmpeg the hard way, which is like this post on GitHub with some tutorials, and it explains conceptually how FFmpeg works. So it shows that, I think, let's see where it says that. The infamous hello world. Yeah, it's this. It must be this. Yeah. So the architecture is, you've got inside a file, you have the decoder of the file that reads the file format, the MPEG-4 container, is the AV format context, and you use the AV format library to decode or to read in those files. They give out these AV streams, and interleaved you have different packets of different streams in the file. Like they'll put in an audio packet and then a video packet and then an audio packet and then a video, or maybe interleaved in a different way. And those packets, they might be out of order, and that's why you will need to sometimes provide more packets before the decoder will give you a frame. But I heard something about an AV packet containing potentially multiple frames of video inside a single packet. So I'm not so sure. Yeah, I'm aware with the PNB frames that they're diffs. And especially like I don't know which one is the one calculated based on the previous and the next frame, but of course with those you need other frames first, and the way that will be put in the file is the one frame, the key frame that is used to calculate a previous frame. That one will appear in the file before the diff. But yeah, I'm guessing as well, so I don't know. But that's the way I'm conceptualizing it, and the code I'm writing, it's working with my conceptual system. If I'm starting to get really weird bugs, it might be because the way I'm thinking about frames is wrong. But so far it's good. We read out this frame. What I want to do now is, instead of just reading the frame outside of our loop, I want to put it in the loop for now. I want to read a new frame every time I try to re-render. And we'll see how fast it goes. It might be way too fast because it'll just be like running very... it will be doing something weird. But so the way we need to do that is I need to bring my reader close function all the way down. And then... What are you doing?
I'm checking my lamps because I need to replace one. Sorry.
Oh, okay.
Yeah. Alright, I'm turning that off.
Right, I need to keep GLFW make context current here. I want to generate my texture ahead of time. And then all I want to do is just load in a frame and load it into my texture inside the function. So we set up our orthographic projection, read a new frame, and load it into texture. Actually, I want to allocate my frame data there outside, obviously. I don't need that one. What's wrong? Oh, I've already got it. Up there. Generate texture. Generate allocate frame buffer. We don't need to read a frame yet. Inside here, I want to read my frame, and if it succeeds, I want to load it into my texture. So I just need to geo bind my texture. That should work, maybe, I think. Let's see what happens. Okay, so now if I don't move my mouse, the video doesn't move because I've set it to GLFW wait event, so it will block here until a new user event comes in. If I do poll events, it will do an infinite loop. There we go. So this is basically decoding and rendering the video as fast as it can, which is kind of cool. It's pretty fast. Looks like it's maybe double speed, more, like 3 times the speed of the video. It's hard to assess just from looking at my mouth moving. But so that's pretty cool. It's really a simple change here, where I've set up a pretty nice interface between the video decoding code and the rendering code, where all I have to do is just ask it to read a new frame, and it will give me the frame data to put into a texture. I've simplified all of the stuff happening in FFmpeg there. Thank you, Sammy. Thank you. Right. Now I need to get it to go at the right speed, as opposed to, whatever this is, which is very fast. Okay. This is a good place to take a short break. I'll come back in like 5 minutes and start working on timing and synchronization of these videos so that they run at real time and that they get rendered with the right timing. But yeah, cool. What happens when the video ends? Can I change it to a shorter video? Is demo song a shorter video? No. It's pretty cool though. Okay. I'll take a break. I'll be back in 5 minutes. Yeah, time for some PTS DTS stuff. Exactly. Okay, that's what we're gonna do next. Okay.